Hi students, today we will discuss the derivation of junction temperature if two different materials are joined together and the heat is given at one end and it is the transfer of heat takes place to the other end, then what will be the temperature of the junction and what will be the equivalent thermal conductivity of these two substances when joined together. So now you see here, suppose this is the material steel and the other material is here of copper. So the cross sectional area of the steel is A1, the thermal conductivity K1. Similarly for copper this is A2 and K2. The temperature at this end is T1, so at this end this will be T2. So here we will find out the derivation for the temperature, that is junction temperature, that is T0, and also the value of the K, which is the equivalent thermal conductivity when these two substances are connected with each other. So for this, what is the concept that we are going to use? That is the amount of heat transfer between two phases of a body. So we know that the amount of heat which is transferred between two phases, that is here K A T T1 minus T2 upon X. In our earlier derivations already we have discussed this thing. Suppose we have a cubical body, then from one phase to other phase, the amount of heat transfer, that is directly proportional to the cross sectional area, directly proportional to the time, directly proportional to the temperature difference, and inversely proportional to the thickness, that is the distance between the two phases. So similarly this formula, so here if we want to rate of heat transfer, then this will be your Q by T. So Q by T will be equal to Ka, this is T1 minus T2 upon X. So this formula we will be using here. Now when the heat transfer takes place from this end to this end, then we can take that the amount of heat transfer from this end to this end, that is rate of transfer of heat, will be same in different sections of the material. So here the rate of transfer of heat from this end to this end will be equal to the rate of transfer of heat from this end to this end. So from this end to this end, the rate of heat transfer we can represent by using this formula. So this will come as K1 A1, this is T1 minus T0 upon L1. Similarly, the rate of transfer of heat from this place to this place will be your K2 A2 T0 minus T2 upon L2. So if here we assume that these two substances, different materials, they have the same cross sectional area, so that is A1 is equal to A2 is equal to A, and the length between this and this will be same, so L1 is equal to L2 is equal to L. So here this will be cut, this will be cut. So we'll find that K1 T1 minus T0 will be equal to K2 T minus T2, T0 minus T2. So if we change this thing, so we'll find this T0 will be equal to K1 T1 plus K2 T2 upon K1 plus K2. So this is the derivation for the junction temperature. Now to find out the equivalent thermal conductivity when these two different materials are joined together and the heat transfer takes place, here we can say that the rate of heat transfer from this end to this end will also be same as the rate of transfer of heat between these to this or between these to this. So here suppose we consider that heat transfer from this end to this end. So what will be the formula? So here the formula will be equal to here K1 A1, this is T1 minus T0 upon L. So this will be equal to the rate of heat transfer from this point to this point. So here we can equate. So in this case what will happen? Let the thermal conductivity of this, the total combination is the equivalent thermal conductivity which we are considering as K. So K means this is equivalent thermal conductivity of the combination. Thermal conductivity of the combination. So here this will be equal to your K A. Now this will be equal to T1 minus T2, and the length for this case, you can observe the length, this is L1, this is L2, so we have equated, so this was L, so the total length will be 2L. So here, by putting the value of T naught, as we found out, we can put the value, so this is A1, that is your A, so this will be equal to T minus T naught, so the T naught value we can put like this one, K1 T1 plus K2 T2 upon K1 plus K2. So this will be the same. Like same manner, we can find out here, this will be equal to your K A T1 minus T2 upon 2L. So by equating these two, we can find out here the value of K will be equal to 2 K1 K2 upon K1 plus K2. So this is the derivation for the equivalent thermal conductivity of two materials when they are joined together and the transfer of heat is taking place. So this is a very important formula to find out the junction temperature and the equivalent thermal conductivity of the joint or of the combination. Thank you.